Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing the chapter called as magnetism. Let's see the numericals of magnetism. A bar magnet has a magnetic moment of 10 ampere meter square. A bar magnet has a magnetic moment of 10 ampere meter square and a magnetic length of 5 centimeters and a magnetic length of 5 centimeters. Find the pole strength. Find pole strength. Straightforward formula. Magnetic moment is pole strength into magnetic length. Answer should be 200 ampere meter. Next, take down next one please. Calculate the dipole moment. Calculate the dipole moment if the pole strength is 30 ampere meter separated by a distance of 18 centimeters. Separated by a distance of 18 centimeters. Right? Now magnetic dipole moment is pole strength into magnetic length. Again straightforward multiplication. Answer for this sum should be 5.4 ampere meter square. Next, take on next one please. Determine the magnetic dipole.
There ampere meter square or
Meter. There you are finding out pole strength. Here you are finding out magnetic moment. Pole strength is ampere meter and magnetic moment is ampere meter square. Next, calculate the magnetic dipole moment. Calculate the magnetic dipole moment if the geometric length is 6 centimeters. If the geometric length is 6 centimeters and pole strength is 100 ampere meter. First, let's find out the magnetic length. Magnetic length 2L is given by the formula 5/6 into geometric length. You know the geometric length, so you come to know magnetic length. Magnetic moment is pole strength into magnetic length. Magnetic length, you know, pole strength is given to you straight multiplication. The answer for this sum should be 5 ampere meter square. Next, take down next one please. Calculate the magnetic induction. Calculate the magnetic induction due to a short magnetic dipole. Due to a short magnetic dipole of moment. Due to a short magnetic dipole of moment 0.1 ampere meter square at an equatorial point 1 centimeter away. At an equatorial point 1 centimeter away from the center. If mu 0.4 pi is 10 raised to minus 7 Webers per meter square. Sorry, Webers per ampere meter. Webers per ampere meter. Right? Now, they want you to find out the magnetic induction along the equator. Magnetic induction along equator is nothing but mu 0.4 pi m upon r cube. M r mu 0.4 pi. All the values are given to you. Straight multiplication again. Answer is 0.01 Webers per meter square. Next. Take down next one please. A short magnet produces magnetic induction. A short magnet produces magnetic induction of 4 into 10 raised to minus 5 Tesla at an equatorial point at a distance of 10 centimeters from the center. At a distance of 10 centimeters from the center. If mu 0 upon 4 pi is 10 raised to minus 7 Webers per ampere meter, find the dipole moment. Find the dipole moment. Find dipole moment. Now, this is equatorial point. B equator is nothing but mu 0.4 pi m upon r cube. M is the only unknown. Straight multiplication again. You should get the answer for this sum as 0.4 ampere meter square. Next, take our next sum please. Determine the magnetic induction if magnetic dipole moment is 5 ampere meter square at a distance of 100 centimeters at an angle of 60 degree with the axis. At an angle of 60 degree with the axis, if mu 0 upon 4 pi is 10 to the power of minus 7 Webers per ampere meter. Now guys, here they haven't said that this is along, here they've given you the angle, so obviously this is neither along the axis nor the equatorial point, so I can say that B is mu 0 upon 4 pi formula m upon r cube. We've done this derivation, square root of 3 cos square theta plus 1 m r theta. Yes, I have all the values. I should be able to get the magnetic induction. That will give me the magnitude of magnetic induction. Next, I also need to know the direction of magnetic induction. I also need to know the direction of magnetic induction, where I can say that tan phi is nothing but half tan theta. I know theta already, so I'll come to know the direction of magnetic induction. Here, although they haven't asked you, I'll show you this. I can also find out the magnetic potential. Magnetic potential will be mu 0 upon 4 pi m cos theta upon r square. So that will give me the magnetic potential. So all three values can be found out here. The answer for the sum should be magnetic induction is 6.615 into 10 raised to minus 7 Webers per meter square. Theta phi should be 40 degrees 54 minutes, and magnetic potential should be 2.5 into 10 raised to minus 7 joules per ampere meter. Next, let's see another sum, guys. A point is situated at a distance of a point is situated at a distance of 20 centimeters. A point is situated at a distance of 20 centimeters from the center of magnetic moment of magnetic moment 8 ampere meter square at an angle of 30 degree with the equator. At an angle of 30 degree with the equator, find the magnetic induction. Find the magnetic induction and magnetic potential. Find the magnetic induction and magnetic potential. Now guys, you have to pay attention here. They have given you at an angle of 30 degree with the equator. Remember, the angle has always got to be measured with respect to the axis, right? So when they say with respect to equator, how do you get the angle with respect to axis? Whatever is the angle, 90 minus that given angle. So theta is going to be 60 degree here. Then it's a straightforward sum. B is nothing but mu 0 upon 4 pi m upon r cube square root of 3 cos square theta plus 1. Once you have this, I can also find out tan phi is half tan theta. That will give me the direction. And magnetic potential is nothing but mu 0 upon 4 pi m cos theta upon r square. All the three values can be found out. It is replica of the previous sum. Answer, you can say that magnetic induction B is 1.323 into 10 raised to minus 4 Webers per meter square. Phi is 40.54, 40 degrees, 54 minutes. And magnetic potential is 10 raised to minus 5 joules per ampere meter. Next. Determine the pole strength. Determine the pole strength. Determine the pole strength if the magnetic length is 2 centimeters at a point 20 centimeters at an angle of 30 degrees with the axis, at an angle of 30 degrees with the equator, sorry, not axis, at an angle of 30 degree with the equator, if the magnetic induction is 3.75 into 10 raised to minus 5 Webers per meter square. If the magnetic induction is 3.75 into 10 raised to minus 5 Webers per meter square. Right? Again here they give you an angle of 30 degree with the equator. 30 degree with the equator means with the axis it will be 60 degree. Once you have this, then first you will use the magnetic induction formula mu 0 upon 4 pi m upon r cube square root of 3 cos square theta plus 1. Right? Once you have this, from here you will get the value of m. First you use this formula to get m. Once you get m, then you can say magnetic moment is nothing but pole strength into magnetic length. Magnetic length is given to you, so you should be able to get the pole strength. The answer for this sum should be pole strength is 113.4 ampere meter. Next. The magnetic induction at point P, the magnetic induction at point P is equal to the magnetic induction at point Q. The magnetic induction at point P on the axis, the magnetic induction at point P on the axis is equal to the magnetic induction at point Q on the equator. Compare the distance of P and Q from the center. Compare the distance of P and Q. Compare the distance of P and Q from the center. Let us assume that RP and RQ are distance of P and Q from the center, right? In which case I can say at point P, I can say BP is going to be mu 0.4 pi 2m upon RP cube, right? It's along the axis, therefore it will be 2m upon r cube. At point Q, BQ is going to be mu 0.4 pi m upon RQ the whole cube, right? Along the equator it is m upon r cube, but they give you that BP is equal to BQ, therefore mu 0.4 pi 2m upon RP the whole cube is mu 0.4 pi m upon RQ the whole cube. So mu 0.4 pi gets cancelled, m and m gets cancelled, so in which case I'll get R2 is RP upon RQ the whole cube. Therefore I can say that RP upon RQ is nothing but cube root of 2. How do you find this out? Find log of 2 divided by 3 and find the anti-log of that. You should get the answer. The answer for this should be 1.26. Next, take on lesson please. It is found that the horizontal component, it is found that the horizontal component of Earth's magnetic induction is balanced by magnetic induction of short magnetic dipole, is balanced by magnetic induction of short magnetic dipole at a distance of 20 centimeters, situated along equator. Calculate the magnetic moment. If the horizontal component is 4 into 10 raised to minus 5 Webers per meter square. 4 into 10 raised to minus 5 Webers per meter square. Now they said that horizontal component has been balanced by a point along the equator. That means I can therefore say that B equator will also be equal to 4 into 10 raised to minus 5 Webers per meter square. Once I have this, I can say but B equator is nothing but mu 0.4 pi m upon r cube. Mu 0.4 pi we know is nothing but 10 raised to minus 7 SI units. Mu 0.4 pi is 10 raised to minus 7 Webers per ampere meter. So I know B equator, I know R. So I'll get the magnetic moment here. So first thing I'll do is I'll find out the magnetic moment. Once I know the magnetic moment, I can say magnetic moment. And that's what they've asked you to find out. Find the magnetic moment. Next, take our next sum. The answer for this sum should be 3.2 ampere meter square. Next, take our next sum, please. Find the magnetic potential. Find the magnetic potential at a distance of. Find the magnetic potential at a distance of 10 centimeter and at an angle of 45 degree with the axis. If the magnetic moment is 0.8 ampere meter square. If the magnetic moment is 0.8 ampere meter square. If the magnetic moment is 0.8 ampere meter square. Straightforward sum again. Magnetic potential mu 0.4 pi m cos theta upon r square. I have m, I have theta r. I should be able to get the answer for this because I know that mu 0.4 pi is 10 raised to minus 7 Webers per ampere meter. So that should be able to get me this answer. The answer for this sum should be equal to 5.658 into 10 raised to minus 6 Webers per meter. Next, take our next sum, please. A bar magnet of magnetic length 0.02 meter has a pole strength of 4500 ampere meter. Find the magnetic potential. At a distance of. Find the magnetic potential at a distance of 0.3 meters along the axis. 0.3 meters along the axis. Now since it is along the axis, that means theta will be 0 degrees. First of all, I can find out magnetic moment, that is pole strength into magnetic length. Next, they have asked me to find out magnetic potential. Mu 0.4 pi m cos theta upon r square, where I can say that mu 0.4 pi is 10 raised to minus 7 Webers per ampere meter. Should be able to get the answer for magnetic potential. Answer for this should be 10 raised to minus 4 joules per ampere meter. Next, find the difference in potential of 2 points. Find the difference in potential of 2 points lying on the axis at 50 centimeters and 100 centimeters and 100 centimeters from the center if the magnetic moment is 3 ampere meter square. If the magnetic moment is 3 ampere meter square. Right? Along the axis, therefore theta is 0. Now we know that magnetic potential is mu 0 upon 4 pi m cos theta upon r square. Now since theta is 0, therefore this formula is going to be modified as mu 0 upon 4 pi. Cos of 0 is 1, so this will be m upon r square. Along the axis, this should be the formula. I can say therefore, they have asked you to find out the difference in potential. Difference in potential is nothing but mu 0 upon 4 pi m upon r1 square minus mu 0 upon 4 pi m upon r2 square. So v1 minus v2 is mu 0 upon 4 pi m 1 upon r1 square minus 1 upon r2 square. Right? Now, once you have this, you can substitute this and get the answer. You will get your answer as 9 into 10 raised to minus 7. 9 into 10 raised to minus 7 Webers per meter. That will be the difference in potential. Next, take down next one please. The potential due to a short magnetic dipole, the potential due to a short magnetic dipole is 10 raised to minus 5 Webers per meter at an axial point at a distance of 20 centimeters. At a distance of 20 centimeters, find the magnetic moment also find the potential on the equator. Since the point is on axis, theta will be 0 degree. Magnetic potential is nothing but mu 0 upon 4 pi m cos theta upon r square. V is given to you. You should be able to get the magnetic potential. The magnetic moment they've asked you to find out. So you will get this. Now at equator, theta will be 90 degree and cos theta will be cos 90, which will be 0. Therefore, magnetic potential along equator will be 0. Right? Answer for this sum should be magnetic moment should be 4 ampere meter square. Next, take down next one please. The potential at a distance of 20 centimeters, the potential at a distance of 20 centimeter and at an angle of 60 degrees is 3 into 10 raised to minus 7 joules per ampere meter. Find the magnetic moment also find the magnetic induction at a distance of 50 centimeters. Also find the magnetic induction at a distance of 50 centimeters. Also find the magnetic induction at a distance of 50 centimeters. First of all, they've asked you magnetic potential mu 0 upon 4 pi m upon m cos theta upon r square. V is given to you, theta is there, r is there, so you should be able to get the magnetic dipole moment. Second part of the question, they've asked you to find out, also find, can someone just read the last part of the question to me?
You find the magnetic induction at distance of 50 centimeters.
Along the axis, just make that correction. At a distance of 50 centimeter along the axis. Now along the axis means theta will be 0 degrees. Distance for magnetic induction is given to you as 50 centimeters. So this can be written as 50 into 10 raised to minus 2 meters. Magnetic induction mu 0 upon 4 pi. Now along the axis, that is going to be 2m upon r cube. Magnetic moment you would have found out from part 1, r is given to you, theta was 0, so you should be able to get this answer. You will get magnetic moment should be 24 into 10 raised to minus 2 ampere meter square, and magnetic induction is 3.84 into 10 raised to minus 7 Webers per meter square. Next, take down next one please. The magnetic potential at 0.4 meters and at an angle of 30 degrees with the axis is 10 raised to minus 4 joules per ampere meter. Find the magnetic induction at that point. Find the magnetic induction at that point. Find the magnetic induction at that point. Now first of all, since magnetic potential is given, I can say mu 0 upon 4 pi m cos theta upon r square, right? So I will be able to get the magnetic potential, magnetic moment from here. Once I get the magnetic moment, they have said that they've asked me to find out the magnetic induction. B mu 0 upon 4 pi m upon r cube square root of 3 cos square theta plus 1. Substitute the values and you should get this answer. The answer for this sum, m you would have already found out from there. You should get the answer for this sum is magnetic induction should be 5.206 into 10 raised to minus 4 Webers per meter square. Next, the magnetic potential at a distance of 30 centimeters and at an angle of 30 degrees is 5 into 10 raised to minus 7 joules per ampere meter. Find the magnetic moment. Also find the magnetic induction. At an angle of 45 degrees at an angle of 45 degrees and at a distance of 50 centimeters from the dipole. Now V is mu 0.4 pi m cos theta upon r square. V is given to you, theta is given to you, r is given to you. So from here you will be able to get the magnetic moment. Once you have this, then they said that theta is 45 degree and r is 50 centimeters. So 50 centimeters can be written as 50 into 10 raised to minus 2 meters. They have asked you to find out the magnetic induction. Magnetic induction is mu 0.4 pi m upon r cube square root of 3 cos square theta plus 1. So from here you will get the magnetic induction. The answer for this sum should be, you should get magnetic moment. Magnetic moment should be 51.96 into 10 raised to minus 2 ampere meter square, and magnetic induction should be 6.572 into 10 raised to minus 7 Webers per meter square. Right? Next, let's see another sum, guys. The magnetic potential at a distance of 0.25 meters and angle of 60 degrees is greater than the magnetic potential at a distance of 0.5 meters along the same line by 3 into 10 raised to minus 7 joules per ampere meter. Find the magnetic moment. Find the magnetic moment. Mu 0.4 pi m cos theta upon r1 square. Right? Similarly, I can say V2 is mu 0.4 pi m cos theta upon r2 square. They give me that V1 minus V2 will be nothing but mu 0.4 pi m cos theta common. This will be 1 upon r1 square minus 1 upon r2 square. V1 minus V2 is given to you. The only unknown in this equation is going to be m, magnetic dipole moment. You should get the answer for this. The answer for this sum should be m is 0.5 ampere meter square. Next, take down next sum, please. Find the ratio of the magnetic potential. Find the ratio of the magnetic potential at two equidistant points. Making an angle of 30 degrees and 70 degrees. Making an angle of 30 degree and 70 degree. V1 is mu 0 upon 4 pi m cos theta upon r1 square. V2 is mu 0 upon 4 pi m cos theta upon r2 square. You have to find out V1 upon V2. So you will get this as r2 square upon r1 square. Therefore V1 upon V2 will be nothing but r2 upon r1 the whole square. Right? You should get this answer as 1.462. Right? Okay. We'll stop this here for the day. Thank you very much.